Welcome everybody. Thank you for being here. We have a nice group, and yeah, we would like to welcome you to today's webinar, Getting High with Lidar, how lasers lift aircraft MRO to new heights. Lidar is a very exciting technology, and you will be able to learn something today, maybe get inspired. You will be able to ask a few questions if you have any in between, so feel free to use the Q&A section. And then we will get back to you. And without further ado, I want to introduce today's speakers. We have Dejan Borota, who is the director of Mainblades. We have Andrew Moakes today here as well, the co-founder of Evitado, and Nicolas, baroan, business developer at Ouster. So very exciting guests, so stick around, lots to learn today. And yeah, I think it's good if we do a short introduction round. Let them give them the floor to introduce themselves. Maybe Dejan, do you want to kick it off?
I'm gonna pass the stick immediately to Nicolas to start off. So you introduce us from left to right. Yeah. Nicolas, can you give the people a bit of who you are, what you do?
Yeah, sure. So good afternoon, everyone. So my name is Nicolas Baron. So I'm the business developer at Ouster Europe. So we are based in Paris. And I'm dealing with most of our robotics customer in Europe, Middle East, Africa, and also industrial customer, people using our LiDAR for a lot of different applications, but we're going to talk about later. Yeah.
Great, thanks. And then one of my colleagues, Andrew. Andrew, maybe a short word.
Yeah, first I just want to say thanks for having me. It's great to be here. I'm excited for the discussion. So I'm Andrew Moakes. I'm one of the co-founders of Evitado Technologies. We are a startup based in Hamburg in Germany. And yeah, we're using LiDARs in our technology that we're developing to help move aircraft on the ground.
Cool. My name is Dejan. I'm one of the co-founders and CEO of Mainblades. And we have been hosting this webinar series. Now this is the second time. For the people that were here previously, the previous time we were talking about aviation and innovation in aviation, and we like to host this webinar series and challenge people with innovation, aviation technologies. Today we brought together ourselves and this group of nice people to talk about LiDAR, because this is one of the leading innovations, at least for these three companies. The one thing that actually triggered us to discuss this openly with you is one of the biggest one of the statements of the biggest entrepreneurs in the world, and we all see him as a role model, I think. But one of the cool things he said is LiDAR is a fool's errand. So he really challenged us to the core, because we're all involved with LiDAR, and everybody who's using LiDAR is doomed. Today we're going to explain to you why this, at least for our applications, at least in our world in the aviation, this does not hold. And actually LiDAR is the enabling technology that makes sure that Mainblades is able to build its application around LiDAR. Evitado is able to build an application around LiDAR, which highly is going to benefit aircraft MRO and indeed lift that MRO into the air.
Yeah, so thanks, Dejan. I think that's really a good way to start the discussion here, because something you need to we need, I think, maybe to put a bit of color or context on these quotes, because Tesla was a company about making and selling cars.
Yeah.
So when they say that, when Mr. Musk say that, you need to take into account that it's only about people using cameras, LiDAR for automotive. But if you take a step back and you watch the entire market, you can see that today there are a lot of crazy people, because you have ton of people using LiDAR in very, very different application. And even inside the automotive, you have plenty of other challenging companies using LiDAR. And I think the reason for that is, at the time when they decided to, for instance, if we go back to Tesla, when they decided to go for camera-based systems, it was like maybe 2010, something like that. So, the LiDAR has significantly improved since that date. So we are talking here now today about LiDAR sensor, which can be very light, like below 500 grams. We are talking about LiDAR with different resolution. We are talking about LiDAR sensor with a different level of robustness.
Can I ask a question, Nick? You mentioned that you are the representative for Ouster in Europe for all sorts of robotic applications. Exactly. And now you mentioned that indeed for automotive, maybe it's not LiDAR, maybe it is. But what have you seen? What is the most interesting things you've seen from your point of view that applications that are using LiDAR in an innovative sense?
I think one of the most, let's say, significant improvements we can see in the LiDAR adoption is probably in the drones markets. The reason is not because I'm your host for this webinar, but it's mainly because in the past, when you want to lift a LiDAR sensor or another type of sensor, the first thing you need to take a look is the weight. How big is the sensor, or how expensive is the sensor. And now you can see plenty of companies using LiDAR on a drone because thanks to semiconductor technology, LiDAR can be really light, can be really cheap, and can bring, let's say, enough density in terms of pixels so you can easily put it on your drone and use it just like a camera. So at the end, for your software, it's going to be just like pixels. No one cares if it comes from camera or from LiDAR, but you have kind of pixel with information in the range with the coordinates. So that's definitely, for me, I think the drones, it's really a good representation of what the LiDAR can do today, what type of market it can enable.
Yeah, I think the advancement that has been made in the last couple of years, then Nicolas can show us, is also what has enabled us to actually move away from the, let's say, classical LiDAR suppliers of 10 years ago, which were only a few and they made extremely expensive LiDARs, and how that progress has been made over time to allow actually relatively low cost, better reliability and compact LiDARs. And I think this is then the path that it's taking, and that has invited us to look into Ouster LiDARs.
Yeah, and I think again here, if you take a look on other type of market, like even the consumer, you can see that Apple, even in the smartphone, they are moving to LiDAR, to digital LiDAR, because that's definitely maybe the answer to solve like all the cost issue, the reliability issue, the resolution issue, because with the semiconductor scale we have, in a lot of industry, consumer devices, but also different type of other business, you have this power to make things very, very small, to make things very, very efficient, and to bring extra resolution compared to putting by hand single analog diode, single analog receiver, which make system very complex. And Apple is definitely a very good example of the progress of the LiDAR. Yeah.
It's a great one, and one of the things you mentioned, you mentioned now a lot of technical capabilities, but of course we're also looking at it from a business perspective. It has also enabled a low cost LiDAR, a relatively low cost LiDAR. And the next slide has a very good statement about this, I think, because when I heard, again, you have the LiDAR versus camera discussion a lot of the times, right? And also, then what people say is LiDAR is still expensive. It's still a couple of hundred, maybe a couple of thousand euros, depending on what kind of model, what kind of manufacturer you have. But I remember, I just talked with Mike also about this a couple of years ago. You had only phones, which were normal phones to call and to text with. Cameras were hugely expensive, separate machines, which only professionals used for certain things. For me, that's why I like your comment about Apple. For me, the catalyst of cameras becoming cheaper and more usable was actually the application into consumer electronics. It has driven the price of cameras, of high quality lenses, of systems being able to capture images from hundreds or thousands of euros up to indeed $5, 5 cents, something ridiculous. I think LiDAR is at the forefront of making this leap. I hope that it will not go down all the way to €5 for LiDAR. Otherwise, there's no business, of course. But it will be a catalyst, I think, for what's going to happen to this technology, because it's maturing, and it's just the passage into consumer electronics is going to be a huge step forward, I think.
Yeah, I think you're completely right, and the comparison you did is exactly a very good example. With the analog CCTV camera, and then you have the first camera on your phone, which was like VGA, so 640 by 480. It was a revolution, very expensive, and now you have like 10 million megapixel free cameras on your smartphone, and that's exactly the trends we see on the Lidar, so it's just the beginning.
Exactly. And now the hottest new thing you can get on an iPhone is a Lidar, actually. And so it's starting. It's very exciting. I'm very curious to see what's going to happen in this year, because it's going to drive up the industry significantly to improve further.
Yeah.
And I think what the next part of our discussion is then, we're going to zoom in a bit more how we are using Lidar. So what are the things that Mainblades for one side, Evitado on the other side is looking out for, and what the challenges are. And I think that also very well sets us apart again from the, let's say, 2D car industry. Mike, next.
Before we move on, I think it would be nice to, if Andrew maybe could shed some light on the considerations that were actually made when going for Lidar, because I think he told me up front that there was some considerations whether maybe to use cameras instead, or radar, or ultra-wideband. So maybe you can shed some light on the decisions there.
Yeah. So we actually, our project or our company kind of was came out of a university setting. So we spent a lot of time early on doing research. My co-founder wrote a couple of papers about the different technologies that could be used for the application that we're currently tackling. And I mean, we looked at the first sensor type that we looked at was ultrasonic. We're doing collision avoidance systems, and a really easy comparison is a collision avoidance system in a car. And obviously, they're using ultrasonic sensors. But these types of ultrasonic sensors for us are they're very simple. The type of data you're getting out of it is very simple, analog most of the time. And the sensors have a very short range. We looked at, the next step up from that was radar, a slightly longer range. But again, the type of data you're getting out of it, it's just, we couldn't work with it that easily. And then, the big question is between Lidar and camera. And ultimately, we decided for Lidar because of the situations that we want to use the tool that we're developing. We want to use it daytime, nighttime, indoors, outdoors, kind of any sort of light setting. And again, we'll see some pictures in a little bit here of the type of maps and the type of data, type of situations that we're tackling, and really trying to differentiate with the camera all the the complexity of the environment here in terms of detecting range and detecting distance to certain objects. Using a camera really wasn't a viable option. So then the last step there was Lidar. And as I said, we brought this out of a university setting. We had a professor that was kind of not really, I wouldn't say an expert in this type of technology, but he had used it in the past, and they had some Lidars sitting around their department. And when we said, yeah, we're going to go with Lidar, he kind of laughed at us and said, like, you can't use this type of technology in this tool. It's like, one, it's way too big and heavy. And two, the type of data you're getting out of it is very limited. And he said, well, we're going to try it anyway. And he said, okay, we'll come and pick up the sensor that we have here. Showed up at his office, and it was a huge brick. I mean, it was giant, right? And it ended up being a 2-dimensional Lidar. So yeah, I mean, there's a huge step from 2-dimensional Lidar data to 3-dimensional Lidar data.
Yeah,
so
let me check in on that, because the environment we're talking about, I think you mentioned it, is this. It's a hangar environment, it's an aircraft environment around an aircraft for both of us. So Mainblades is looking at manual visual inspections, where you already see this guy, he's climbing the stairs, so he's not on the floor, he's not looking at a 2D world, and he's looking at a 3D object. So a 2D sensor is required a lot more computational power afterwards. And for for Evitado's point of view, you're looking at collisions, aircraft collisions.
Correct.
And I think apart from the obvious, which is also for us day, night, different weather, is also you will always be working in a different environment, right? So one hangar is not the same as the other. One aircraft is not the same. So you have to have a reliable data input in any situation.
Yeah, definitely. Yeah, I mean, what was really important for us when choosing the sensor type was that it was lightweight. We're developing a tool that's it's a plug-and-play solution, so it's a temporarily installable tool. The ergonomics of using it are really important. It needs to be lifted, kind of overhead sometimes. And it was important also that we had a sensor type that the data could be manipulated. We need to be able to create this kind of 3-dimensional world around the sensor and around the aircraft in order to, detect potential collisions. And so, the data that we're able to collect in with Lidar is really above anything else that's out there.
Yeah. To our audience, this image shows actually the two applications that we have developed. On the right hand side, you see the Evitado's collision avoidance sensor, and on the below side you see the Lidar, the Ouster Lidar there, which is the key enabling technology. And for Mainblades, you see our aircraft inspection drone, an industrial inspection drone with a computer module on top, and the Lidar sensor below, where we also use in a similar way the Lidar as the eyes of this drone, as the eyes being able to look at an aircraft, look at the environment around an aircraft, and actually being able to make these kind of 3D point clouds, 3D maps of the whole environment. And this is also a nice picture to see. So maybe you can zoom in on what we see here, Nicolas. What kind of data does Lidar actually give us?
Yeah, so typically data from the Lidar will be what we call a point cloud. So that's typically, if you're familiar with 3D stereoscopic, that's typically a kind of depth map range information for every single pixel. So this is the one you see on, depending on the additional software layer you put on top, but you clearly have a kind of perception of your environment in 3D. And for every single point, you have the range information, the signal intensity. So you have completely advanced camera, I would say, because at the end, it's easy for you. So you can imagine for your computer, it's going to be easy for the computer to recognize aircraft, to detect pedestrian, because the more pixel you have, the easier it will be for you as a human eyes, and it's going to be the same for your computer. So yeah.
Yeah, and what we see for our application industry, so doing inspections with drones, we're not the only one attempting this, but what we do see is that we are the only one being able to do this in a dynamic environment. So in an environment, in a hangar where there's maintenance operations busy, there's people around it, the aircraft is not always parked in the same location, there's equipment moving around, and the key reason why we're able to do that, of course, we have our software stack, but enabling technology allowing us to see all of this real time is the Lidar. We continue getting scans all the time. We make a model like you see in this picture on the left side. We make a model of the aircraft. We navigate based on the model, but we continue to observe everything around us from these Lidar measurements. And I think Evitado has a very similar use of this data on a continuous basis, right, Andrew?
Yeah, definitely. Yeah, I mean, I can just touch on, our decision of using Lidar over ultrasonic sensors again. You could, in theory, just like you kind of do in a car, you could kind of install ultrasonic sensors all around the aircraft. But again, it's important for us that our system, our tool is a plug-and-play solution. And so it really, in this case, it doesn't make sense to install, some sort of sensor on the wingtips, because you'd have to pull out, some sort of lifting device every time to install the tool. And it really doesn't make sense. So what was important for us was that we could install something centrally, kind of under the aircraft or close to the aircraft. And we can get then, much better data from one single sensor rather than having multiple sensors installed all around the aircraft based off of this 3D point cloud.
Yeah, what I think is also a nice addition to your tool, Andrew, is that you can you're placing it now on the aircraft, but potentially you could place it on all kinds of different vehicles or infrastructure in or around the aircraft, or in a hangar, maybe even wider, and use it as a sort of a 3D model, real-time model in the world to do all sorts of, I don't know, navigation, collision avoidance, whatnot.
Yeah, definitely. I mean, we're exploring the possibility of even installing it in the infrastructure of the environment that we're moving, and then having mobile sensors, stationary sensors, kind of working all together. And like you said, we could install it on kind of any vehicle that we need to move, any big asset that we need to move. Plug and play. It's really easy. Yeah, I mean, it's a really exciting technology that I think is going to go a lot of places that we don't even know yet.
Over the last couple of years, I've talked to a lot of maintenance people, MRO managers, airline managers, and I've repeatedly heard the phrase a hangar of the future, which is a sort of a conceptual environment where people, at least before the COVID pandemic, were heavily investing in future technologies to make sure that aviation maintenance in hangars is still going to be prime time. I think sensors like yours and the technology like Lidar is almost a must-have in a hangar of the future, to be able to optimally park your aircraft, to be able to remove your aircraft without any collisions, and to be able to inspect your aircraft based on with drones based on the environment that the drone is operating in. So I think if you're looking to build a hangar of the future, LiDAR will be definitely part of that.
Yeah,
that sense,
and I just
a question on here for you, Dan. I think what is actually being inspected then on the aircraft?
On the aircraft, we use LiDAR to navigate our drone around the aircraft, and with a separate sensor, a camera, a visual camera, we make pictures of the fuselage. And with that, aircraft engineers can actually do the assessment of an aircraft much quicker. So we use the same technology as Evitado does, but in a completely different way. So we're not really doing anything with the aircraft and the LiDAR, but we're using the LiDAR as an enabling means to utilize our drone technology to do the inspection. But the concepts of using the information, the sensor information, is very similar.
Yeah.
Yeah, so that's about, what's our next slide? I think that's about it. So what we wanted to show you with this, that in our industry, in the aviation industry, LiDAR is actually, we're not doomed. This is going to be used for applications which are really going to help digitalize and automate MRO processes, being it parking aircraft, being it inspecting aircraft. Good last slide, maybe. I think we all see what we can do with the LiDARs now. This is already there. We also in the beginning talked about that LiDAR will become a lot more efficient, a lot more effective, a lot more cost effective also. So what can we expect more from the future? I think Nicolas is the right man to talk about that.
Yeah, I think first of all, the most important thing from the technical side is we're going to see more resolution, more laser, more beams, so more pixel for you. Today, I think the maximum we can get is 128. Tomorrow is going to be 256, maybe 1000 pixel in coming months or years. So it's going to be like really a high resolution, as high as a camera today. And then, of course, because people are still using the semiconductor industry, so you can expect like small, light, and cheaper sensor, which means the LiDAR will be used in many different industries, just like cameras. You have cameras everywhere in the world. We can expect, I think, the same for LiDAR sensor in the coming years, and it's going to be combined, of course, with UAVs and other type of market like that. So I definitely think that it can, as you say, it can enable new professional and survey mapping services that we start seeing, people using LiDAR combining with GPS for mapping the city. So it's just the beginning. Tomorrow, maybe any one of you will have like a LiDAR in your pocket, and you can clearly maybe some map that you're going to capture during your holidays to a platform. Why not? And yeah, that's definitely I think a bridge between the industrial market we know and where we are at the moment with the LiDAR, with a consumer world where the LiDAR could bring definitely additional value for consumer and for every one of us.
Yeah, I think so too. And then go ahead, Andrew.
I was going to say the big question for me is will data storage keep up with this type of technology, right? Because I mean, you're producing tons and tons of data through your 3D point clouds, and so it's really important to then be able to process that much data and to be able to store that much data in the future to be able to use it. And I think that'll be like the next big challenge.
Yeah, definitely. I think I completely agree. Exactly the same as computer vision. You have always a computer vision chip combined with your camera, which process data and so on. So we can expect the same with the LiDAR point cloud. Yeah.
I'm very excited about the shift for professional usage of LiDAR. Similar to what Andrew's story was, we also got our first LiDAR from the university, borrowed it from a professor, and it was collecting dust for months. And actually, that's how we started playing with it. Back then, it was a 2D LiDAR, so we wrote it ourselves. Now we're getting more and more to 3D LiDARs, which require less elements to get actually a better overview. So that has enabled also more professional use of the LiDAR for mapping services. I'm really looking forward to what's going to happen in the coming 2-3 years with this technology. And I know it's helping us to give great services to the aviation MRO and lift that industry again. I think, Mike, go ahead.
Yeah, I think we come close to the end of today's webinar. If you have any questions, now is the time, because you got the experts right here in front of you. So should there be any questions, just type them in.
I see 2 of them in the chat already, Mike. One of them is, I think for me, it says, can it be used to scan and map a particular surface on an aircraft in a detailed view? It surely can. So the question is, can we use it for aircraft inspections? What we do is we map a surface of the aircraft, we map actually a whole aircraft, and then we fly based on that surface around the aircraft. We use that surface mapping with Lidar to make pictures, but we only use the pictures for the inspection, so we don't measure the depth with the Lidar. Unfortunately, at this stage, that resolution is not high enough, but Nicolas just said to you that it's going to be very soon. I do believe that. At this point, a visual inspection with the camera is enough, and the LiDAR is enabling technology to make sure that the camera is in the right positions to make those pictures, for us at least. Anything else, Mike? Do you see anything else?
Yeah, we got another question right here. Do you need a 3D data model? Well, actually, no, sorry. Is the amount of data generated by the LiDAR on your products not a limit in terms of being able to handle all of that in real time? So then we're talking about processing power.
It's exactly what Andrew hinted on. Yeah. I don't know, Andrew, what's your experience with this? Maybe you can tell a little bit, I can tell a little bit.
Yeah, I mean, we definitely have to be very selective on what processors we're using in our tool, because it is a lot of data. But you know, what's important for us is ultimately the size of the processor. So there's, you know, it's very easy to process this much data, but what's important for us is finding a small enough processor that consumes, you know, small enough power, and that fits into a package size that we can, you know, put in somebody's hands and they can manipulate in their hands and install. And you know, that technology is already out there. The processors are already out there. You know, we have a handheld tool, like you saw in the picture earlier. It's about, you know, size of a small shoebox, I would say. So it's very small, lightweight, and we can run that thing for a couple hours at a time, you know, on a single kind of drill battery. So yeah, the technology is out there to be able to process this much data already.
Yeah. I can also say that we've had more difficulties with processing a large amount of images, because this requires GPU processing in our case. But what we've seen from the LiDAR images, actually, that's perfectly suitable for CPU processing. Yeah. Firepower there is more than enough, and we actually never had problem of either doing it post-processing, so collecting data and making models afterwards, or doing it in real time to get our actual drones positioned. So for now, LiDAR is still perfectly capable with the current computational powers in the current industry.
We also have another question in terms of other approaches other than LiDAR and of companies that are doing similar things in the fields that we talked about today. Is there experience with other approaches, or have you seen or have you talked to people that have tried other things in different ways?
Yeah, I'm willing to chip in on that for the drones case. Drones can be navigated based on GPS, which mainly they are. We're using LiDAR to navigate the drone because it allows us flexibility with respect to the aircraft, with respect to the environment, with respect to the weather, with respect to the colors around an aircraft, day, night. So we have a lot of flexibility. Of course, there's also the approach to use drones with cameras, visual systems. I'm not saying that's not a way to go. I think that's also a particularly good way to use it, although you have to have substantially more processing power, either on board your drone or off board, but preferably on board your drone, because you want to use this data real time. I think the future will bring, for drones at least, some kind of joint effort that you use both sensors, because they are in certain ways complementary from each other. And by getting more different sensor inputs, you can actually gather more information and combine them. So in our field, drone inspections, visual cameras are definitely an opportunity as well. But we feel that for our drone, we're flying in a hangar, a 3D environment. We have to see an object, aircraft, a 3D object. LiDAR is the perfect case currently enabling us, but we are pending that with cameras for sure. Andrew, can you maybe chip in on that?
So we have heard of a similar technology to ours. That you know, another company is trying to create something like this, and I've heard that they're using a three-dimensional radar technology. But we've actually had some customers kind of try that out and then come to us afterwards. And I think that the big reason for that is, I think it's very difficult to manipulate this three-dimensional radar data. and the accuracy again is nowhere close to the accuracy that we're seeing from our lidar sensor. I have not seen this other competitor, so I can't give any concrete details on it or answers of why three-dimensional lidar is better, but that's kind of the feedback I've heard from the market. I think Nicolas would probably be able to give more on that.
Yeah, and maybe I have a question as well here for both of you regarding the software side. How would you qualify the integration process for a lidar compared to a camera? Let's assume that you are a company, you're starting with camera, and then you want to get range information. So you are thinking about lidar. Is that a big step for you as a company working on maintenance and anti-collision devices? Is that a big step from computer vision camera algorithm to lidar based how you can use the point cloud? Is that a big step or is it something that can be?
It's a good question. It's a good question. I think it's a matter of having the right personnel. So our company consists mostly of robotics engineers, and I have to say those engineers, robotic software engineers, are schooled both in using computer vision and computer vision tools as using lidar tools. Most of these people know some matter of SLAM, simultaneous localization and mapping, for which both are usable. And I think similar to Andrew and their team, this kind of knowledge comes from university. So if you have the right engineers for this, I don't think there's really a difference in difficulty. You just have to have the right background.
Yeah.
And for the rest, integrating it is quite straightforward then.
Yeah, I think ultimately it's not necessarily harder. I mean, again, I'm not an expert, but it's just a different way of processing the data. A different way that it's manipulated. So, but again, I'm not an expert.
I see another question in the pipeline for us, Andrew, to both to Evitado and Mainblades. The question is whether our solutions are both operational at the moment, and are they being used by airlines and MROs right now?
Yeah, so from our side, yes, it is very much operational, and we do have products in the field, and they're being used by customers at the moment. Yeah.
Yeah. From our side, I can say something similar. I've returned from an operational test and a demo yesterday. We're doing another one tomorrow, so there are definitely airlines and MROs. I have to say they're at the forefront of technology, chasing a higher quality in aircraft maintenance and MRO, but they are using this technology, and this is still a new field, but people are using it and seeing the benefit of this because it is an enabling technology.
Yeah, I mean, people are always excited. The technicians are always very excited to see what this tool is doing and the type of information that it's producing. Whenever we go out and do a demo or show people, what the sensor is actually seeing on the screen, they're always really interested, and we always have a huge crowd
audience
gathered around.
Yeah, we have the same. We have the same.
Yeah, your very first slide of the presentation, there was a big group of people, so I know how it is.
And how does
especially within
question here? How does the cooperation with the OEMs actually look like, Boeing and Airbus? Maybe both of you can shed some light there.
I can shed from my side. Boeing and Airbus are definitely key players in the aviation industry, but they don't have any direct stake into this process. They are setting the standard in terms of what aircraft maintenance should look like. So they set the guidelines. When you have an aircraft, you should maintain it this way so you can keep flying it. How we use this technology is actually one of the ways to enable easier inspections. And I think we're looking with these airframers to OEMs to combine with them to also validate this type of inspection. But it is already by multiple airlines and MROs, we've had the confirmation that this is as good as or better than the current type of inspection, which is a manual inspection by a human walking around. And with a drone, you can actually have a digital inspection and have the results for further reference. So I think the OEMs for us will be happy once this technology has been adopted in a larger scale. Andrew, you have a different story maybe?
Yeah, I mean, as I said at the beginning, we're based in Hamburg. We founded our company in Hamburg, and as you can probably tell by my accent, I'm actually from the US originally. So the question is always, well, why did you found in Hamburg? And the big reason for that is because, you know, we have a big MRO based here and we have a big OEM based here. And, you know, we were lucky enough to get in early with the OEM. And we've been able to, work together with them. And they're moving a lot of aircraft on their facilities. And obviously when they move aircraft on the facilities, there's a big risk of collisions occurring, of accidents occurring. And so they themselves are looking for solutions to try to reduce that. You know, it's definitely, it looks really bad on any sort of quality if a brand new aircraft is damaged in production. So it's really important for them as well. And they're very, you know, they're open to trying out new innovations within their production facilities. The question is always, you know, a big organization like an OEM just takes a lot of time to work with. But ultimately, you know, if they adopt this type of technology in the production facilities, then the MROs tend to look at that as an indication to use it in their operations as well. So that's at least our experience.
Yeah. Mike, do you have anything else?
I think we can wrap it up with two last questions. Otherwise, we are exceeding the time frame here a bit. But I think we've got two specific questions, one for Evitado and one for Mainblades. So let's start off with the one for Evitado. Do the truck drivers that actually move the aircraft, do they get some sort of notification when there is some sort of collision coming up or any sort of warning?
Yeah, so we have developed a tablet-based app. It can be installed, you know, on a tablet, on a smartphone, and it's just like, I mean, it's a user interface, but it's also kind of a feedback loop. So you can imagine like the screen you have in your car that's giving you the feedback of how close you get to something, you know, as you're backing up. That's what we're providing to the tug driver as well. We also provide audible warnings, and we have some LEDs that are installed on our device itself, so they're getting that visual feedback from the device itself as well.
So actually a lot of feedback indeed.
Yeah. I mean, it's very busy environments, right? So,
absolutely.
It's easy to miss sometimes, so you want to give them as much input as possible.
Cool. And then to sum it up, one last question for Dejan here. I think I can combine the last two questions. So, maybe you can give a bit of, maybe you can give some insights as to what drone platform we're actually using, and also how is this drone actually positioning itself within the hangar environment and around the aircraft.
So what we actually use is, and I see another question, is there anything special about Mainblades with this LiDAR technology? I think these two questions combine perfectly because yes, there's something special about LiDAR and about Mainblades. We use that LiDAR to position ourselves with respect to the aircraft. So what we do is we make a model of that aircraft once, and we keep on scanning every time we fly the same aircraft. We don't need another model of this aircraft. We don't need the 3D model of this aircraft. We have our own LiDAR model, and we use the scans from the LiDAR to be able to position and navigate our drone. This allows us to very precisely know from every component of the aircraft where we make a picture, where this picture is taken. If you are interested to see this, give me a call, send me an email. I will be happy to show you how this looks like. I think there are other drones. I think one of our competitors have been mentioned in the question as well. They're working with similar technology or something that looks like this. They're also valid, but we have developed a pipeline for fully automated aircraft inspections enabled by LiDAR to get these images and get eventually a report which is usable for aircraft engineers.
All right, thank you for that. We had very interesting questions spot on for sure. Should there be any more? Should there be any questions coming up after this webinar? Feel free to write down these email addresses from the three hosts today here. Get in touch anytime. Yeah, we hope to see you around. Thank you very much, everyone.
Thanks everybody for joining. Thanks guys for joining the webinar and co-hosting, and much appreciated.
Thanks for having us.
Have a good day.
Bye-bye.
Bye. Bye.